Welcome viewers. In this video we will see the implementation of combinational logic using demultiplexer. Example 1, full subtractor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Implementation of combinational logic using demultiplexer. Here we are going to implement the full subtractor using the demultiplexer. So in the first step, we need to write the truth table of the full subtractor. Then we need to represent the full subtractor in the min term form, because in multiplexer we get the min term as a output. Right. Now we'll see the truth table of the full subtractor. So the full subtractor, the two terms available, a and b. Input is a and b, and borrow from the previous digit. This borrow in, b in. So totally 3 inputs, A, B, borrow in. Right. Then the output is difference between this and borrow out. What is borrow out for next digit? So A, B, borrow in is 3 inputs. Difference and borrow out is the 2 outputs. So because of 3, A, B, B in 3 combination, 2 to the power 3, there are 8 combinations are available. 0, 0, 0, 0, 0, 1 up to 1, 1, 1. Right. Suppose A 0, B 0 and borrow 0. All are 0 means difference is 0 and borrow out also 0. 0, 0, 1. Right. What happens? 0 minus 0 is 0. 0 minus 1. What happens? 0 minus 1. Here the 0 is there. 1. We need to subtract 0 from 1. Subtract. What happened? This is more number. This is lesser number. We need to borrow from previous digit. While borrow it become 10. 10 means 2 in decimal. So 2 minus 1 is 1. So the difference is 1 and borrow also 1. We borrow 1 from previous digit and difference also 1. So 0 minus 1 means we cannot subtract. So we need to borrow from previous digit. While borrow 1 from previous digit, 1 0 become 10. 10 means 2. 2 minus 1, 1. So the difference is 1 and borrow also 1. Right. So 0 minus 1 means difference is 1 and borrow also 1. Here is same thing, 0 minus 1. So the next third one is 0 already, so no problem. So 0 minus 1 means 1, 1. Difference is 1 and borrow also 1. Here 0 minus 1 means difference is 1 and borrow is 1, but here one more 1 is there. So this 1 minus 1 become 0. Only borrow is 1. 1 minus 0 and 1 minus 0, nothing will happen. The difference is 1, borrow is 0. Here 1 minus 0, again 1 minus 1. 1 minus 1 means difference also 0, borrow also 0. Here also 1 minus 1. Difference is 0, borrow is 0. Here 1 minus 1. Both are 0. But 0 minus 1 become 1, 1. 0 minus 1 means difference 1, borrow 1. Right. So now we completed the truth table. Right. So A, B borrow in 3 inputs, difference borrow 2 outputs. Now this is represented, this 0, 0, 0, 0, 0, 1 is represented in min term, M0, M1, M2, M3, M4, M5, M6, and M7. So this is represented in min terms. This corresponding 0, 0, 0, 0, 0, 1, 0, 1, 0. Right. So the difference we have here 1 is available. 1, 2, 3, 4 ones are available. That is corresponding M1, M2, M4 and M7. These 4 are available as high level. So that is the required terms for generating the difference. That is sum of min term 1, 2, 4, 7. This is 1, 2, 4, 7. Right. So difference equal to the logical expression in terms of min terms is given as sum of min term 1, 2, 4, 7. In case of borrow out, again this is 1, 2, 3 and 7. So 1, 2, 3, 7 is available for borrow out. Right. 1, 2, 4, 7 we need a required output for difference. 1, 2, 3, 7 is the required output for borrow out. Right. Now we have the truth table. From that we got the logical expression for difference and borrow in terms of min terms. Right. In terms of min terms. Right. Now we need to go for the demultiplexer. We need to implement with the demultiplexer. We know that demultiplexer is one input 2 to the power n output and n selection lines. This one output is converted into 2 to the power n outputs by using the selection line. The selection line will decide 2 to the power n outputs. That is the demultiplexer logic. One input, 2 to the power n outputs and n selection lines. Here the three variables available, a, b, borrow in. So a, b, c or a, b, borrow in. So 1 is to 2 to the power 3 we need. That is 1 is to 8 multiplexer is needed. In that what we have? We need 3 selection lines. We need 3 selection lines, right? So we need 1 is to 8 multiplexer. That means there are 3 selection lines will be available. What is these 3 selection lines? 3 selection line is nothing but ABC. That is AB borrow in, right? What is the one input? One input is 1. The input is the data in is the, will give 1 as a input. So that we'll got 8 different outputs. The input is given as 1. The selection line is given as A, B and borrow in. We'll get 8 different output. In that we need only 1, 2, 4, 7 for difference. 1, 2, 3, 7 for borrow out. Right? All 8 outputs will be available. In that we need to connect 1, 2, 4, 7 for difference. 1, 2, 3, 7 for borrow out. Right? What is this? Sum of min term. Sum. This is sum. So we need to add. So we need one OR gate here. 1, 2, 4, 7s are connected in OR gate, so that we'll get sum of min term. Here also we need one more OR gate. Now we'll see the logical diagram for implementing full subtractor using the demultiplexer. Right. So this is the 1:8 demux. 1 input and 8 outputs are available. This is the selection line. A, B, C or A, B borrow in. Right. So 0, 0, 0 means we'll get Y0 as a output. 0, 0, 1 means Y1 as a output. Other things are 0. 0, 1, 0 means Y2. 0, 1, 1 means Y3. Similarly, 1, 0, 0 means Y4. 1, 0, 1 means Y5. 1, 1, 0 means Y6. 1, 1, 1 means Y7. According to the input, we'll get. So that is available in our truth table also. Right? So these 8 outputs will be available, but we need for a difference, what we need is 1, 2, 4, 7. Right? So this 1 is connected, 2 is connected, and 4 is connected, and 7 is connected. Right? 1, 2, 4, 7. These 4 inputs are connected. We are not connected. Why not? Why not is not required. So this is OR gate. So sum of min terms. These 3, 4 terms are added together. We'll get the difference. So here we'll get the difference of the full subtractor. Similarly for bar out, what we need? 1, 2, 3, 7. Right? So this 1 is connected. Here 2 is connected. Then 3 is connected. Then 7 is connected. Right? So 1, 2, 3, 7. So here we got the, this is the sum of min terms. So OR gate we are used. We got the borrow out. Right? So we implemented the full subtractor using demultiplexer. Data in is 1. Selection line is nothing but 3 inputs. A, B, borrow in. The 8 different outputs available. Based on the truth table, difference mean we need the sum of min term 1, 2, 4, 7. This 1, 2, 4, 7 is connected together. For borrow out, what we need? 1, 2, 3, 7. So 1, 2, 3, 7 connected. We got the borrow out. So in this video, we discuss how to implement the full subtractor using the demultiplexer. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the implementation of Boolean function using the demultiplexer. Example 2. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Implementation of Boolean function using the demultiplexer. Here 2 functions are given, f1 and f2. 3 variables. The input is 3 variables, a, b, c. That is given as sum of min term. f1, the function f1 having the min term 0, 3, 7. Only these 3 min terms are given for function f1. Similarly, function f2 need a sum of min term 1, 2 and 5. Right. These two functions we need to implement with the demultiplexer. We know that demultiplexer is nothing but one input with 2 to the power n outputs and n selection lines. So this is the basic structure of the demultiplexer. Having only one input that is converted into 2 to the power n outputs, that is done by the selection line. The selection line convert one input into 2 to the power n outputs. Right. Here n is 3. There are 3 variables available. So 1 is to 2 to the power 3. That is 1 is to 8 multiplexer we need. Similarly, we need 3 selection lines. Right. So to implement this function f1 and f2, we need 1 is to 8 multiplexer and 3 with 3 selection lines are needed. What is this 3 selection line? This 3 selection line is nothing but ABC. 3 selection lines are ABC. What is the one input? One input is 1, logic 1. Right. So we got 8 different outputs will be available. For example, 8, 2 to the power 3, 3 variable means 8 combination, 0, 0, 0, 0, 0, 1 like that. In that 8 combination, F1 require only 0, 3, 7. This is sum of min term. So 0, 3, 7 should be connected in one OR gate, so that this OR gate will add these 3 min terms. Similarly, here we need one more OR gate. We need to connect 1, 2 and 5. Right. So now we'll see the logic diagram. So we have the logical expression. Based on that, we decided 1 is to 8 multiplexer is needed with 3 selection line. 3 selection line is ABC. Input is logical 1. 8 different outputs available. In that, we need to connect these corresponding inputs. Right. Now we'll go to the logical diagram. So this is the 1 is to 8 multiplexer Dmax. 1 is to 8 Dmax. The D in is given as 1. The D in given as the 1. Logical 1. These are all 3 selection lines. Based on the value of the selection line, the output will be produced. For example, 0, 0, 0. A, B, C, 0, 0, 0 means Y0 will be available. Y0 will produce the output. This 1 will be available in Y0. All other terms will be 0. If it is ABC is 0, 0, 1, then Y1 will be produce the output. Other terms are 0. Similarly, 0, 1, 0 means Y2 will be produce the output. 0, 1, 1, Y3 will produce the output. 1, 0, 0, Y4 will produce the output. 1, 0, 1, Y5 will produce the output. 1, 1, 0, Y6. 1, 1, 1 means Y7. So these 3 selection line will decide which output will be higher and which are the other outputs are lower. 0, 0 means only Y0 will be higher, 1. All other terms will be 0. Right. Now we got the 8 different outputs. In that function 1, what we need? Only 0, 3, 7. Right. So 0 is available. So this is sum of min term. So we are using OR gate, one OR gate. So here we need to add 0, 3, 7. So 0 is connected and 3 is connected. Similarly, 7 is connected. 0, 3, 7s are connected. So that these 3 will be added together, sum of min term. We got the function f1. Similarly, function f2, what we need? 1, 2, 5. So we connected 1. 1 is connected, then 2 is connected, then 5 is connected. So these 3 inputs are connected. So it will give the sum of min term 1 to 5, function f2. Right. So we got the output by using this 1 is to D8 multiplexer, demultiplexer. We got the logical function f1 and f2. Right. So in this video we discuss how to implement demultiplexer for a logical function. Here the description is available. With D in, input is 1. Demultiplexer gives min terms at the output. Min terms means 0, 1, 2 up to 7. So by logically ORing means sum of min term. By using OR gate, the required min terms we can implement. Required min term means for function we need 0, 3, 7. For function 2 we need 1, 2, 5. Right, that is 1, 2, 5. the required minterms are implemented, so that we can get the Boolean function f1 and f2. So here we discuss how to implement the demultiplexer for a given Boolean function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.